Okay, I'm coming to you again from my car. So bear with me. But what we're going to do today is we are going to solve linear systems by graphing. And this seems confusing, but all we're doing is we're graphing two lines, and the point where they intersect is going to be our solution. Okay, so look at example number 1. Okay, we're going to graph. I like to use colors for this. Well, I like to use colors for everything, but especially stuff like this. So I'm going to call this my green line. So I'm going to start it. It's already in slope-intercept form. I'm going to start it at 1, and then I'm going to follow my slope. I feel like we're jiggly there. Okay, we're going to follow the slope, and we're going to rise 2, run 1. Rise 2, run 1. Okay, and then I'm going to make sure that I extend it backwards, right? So if my slope is 2 over 1, that could be a negative and a negative, right? So down 2 over negative 1. Down 2, negative, down 2, negative. I want to include as many points as I can. Okay, and then I'm going to do my purple line, which is y equals x plus 2. So this one, I start on 2, right? And it has a slope of 1, which is 1 over 1. So I'm starting here, rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, and I can actually stop because I can already see my solution, and my solution is this point right here where they're intersecting, and the coordinates of that point are 1, 3. This is the one value that I can plug in to both of these equations, and it's going to make them true, right? If I use a 1 here, 2 times 1 is 2, plus 1 is 3. If I put it in here, 1 plus 2 is 3. So this is the one number that works for both equations. Okay, let's look at number 2. Okay, we're going to do the same thing. I'm going to do my green line. I'm going to start up here at 4. 1, 2, 3, 4. And then I'm going to follow my slope, which is negative 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. Okay, and I'm going to go as much as I can, just like this. Okay, and then I'm going to graph my purple line, which is y equals x minus 2. So I'm starting down here at negative 2, my y-intercept, and I'm following the slope, which is 1. Rise 1, run 1, rise 1, run 1. Okay, I stopped because I can see the point where they intersected. And that point is 2, 0. Negative 2 times 2 is negative 4, plus 4 is 0. If I plug it in here, 2 minus 2 is 0. Okay, so why don't you guys try the last two, and then we'll come back and check it. Okay, on this one, I have y equals 1/2 x minus 3. Okay, so I'm starting at negative 3, rise 1, run 2, or down 1 over negative 2. So that is my green line. And then my purple line is negative 2x plus 2. So I start up there at 2, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so the point where they're intersecting is the ordered pair 2, negative 2. That would be our solution. And then for example 4, we're going to graph this first line, y equals 3x minus 4. We're going to start it at negative 4. And then the slope is rise 3, run 1. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Connect them. And then my purple line, y equals 1/2 x minus 4. Rise 1, run 2. Look what already happened. They have the exact same y-intercept, right? So negative 4, 0 would be our solution, because that's the one point that makes both lines, or would fit in the equation of both those lines.